G'day. This is the world's hardest easy geometry problem, number 3. It's called that because we can only use isosceles triangles, equilateral triangles and congruent triangles to solve these problems. I have a worksheet which is free to download from my website, and I'm hoping that you will download it and do the problem along with me, because that's how you learn geometry, by doing it. The first triangle I want to look at is AEB, and I see it has angles of 70 degrees and 80 degrees. Well, that means angle AEB will be 30 degrees. The next triangle I want to look at is ADB. I have angles of 80 degrees and 50 degrees. That means angle ADB will be 50 degrees. But that means I have equal base angles. Therefore, the triangle is isosceles, and AB will equal AD. Now I want to construct an equilateral triangle on BE. So I just take that measure with my compass and draw an arc, and then an intersecting arc, and that is going to give me an equilateral triangle. All the angles of my equilateral triangle are 60 degrees. At point B, I already have an angle of 30 degrees. So on the other side of that angle will be another 30 degrees. But that whole angle is 50 degrees. So there'll be another 20 degrees. Now I want to look at the line EA, and I note that there's an angle of 30 degrees at the top, which means the line bisects the angle of 60 degrees. It's actually a perpendicular bisector of the line FB, meeting it at a right angle. Next, I'm going to draw the line AF. And I'm going to label the intersection of AE and FB as G. I see I have congruent triangles, BGA and FGA. They are congruent by side, angle, side, side, angle, side. That will mean that AB equals AF. Also, because I've got congruent triangles, the angle GBA will equal the angle GFA and be 20 degrees. Now the angle at FAB will be 140 degrees, being 180 minus 20 minus 20. And then the angle at FAD will be 140 minus 70 minus 10, which is 60. Now I want to draw the line FD. And look at the triangle DAF. At A, I have an angle of 60 degrees and then two equal sides. The base angles will be equal, 60 and 60. Triangle DAF is equilateral. FD equals AD. Now look at the line BD and extend it to meet FE. At vertex B, I see there are two angles of 30 and 30. So this line becomes a perpendicular bisector of FE, meeting it at right angles and bisecting its length. Now look at the two lines FD and ED. They both come from the ends of that line and meet on the perpendicular bisector. By the perpendicular bisector theorem, those two lines are the same length. Now look at triangle ADE, and we see it's isosceles with equal base angles. DAE equals 10 degrees. DEA is also 10 degrees. There is our solution. X equals 10 degrees. This video is one in a series on hands-on maths. The others you'll find on my YouTube channel, Math with Geoboards. I welcome your comments below. I'll see you next time.